Hello everyone, good morning and welcome to the class. Today let's get started with Terraform. Terraform is an infrastructure provisioning tool. Let us understand this better before we proceed. Right, so let's get started. Are you all seeing the screen? Can you all see the screen? Right. So what is a Terraform? Terraform is an infrastructure provisioning tool. Like till now in your pipeline, if you see, yeah, we are using some EC2 instances, we are using some cluster, like Kubernetes cluster and so on. But all of them we are creating either from management console, like AWS management console, or from the command line, right? Which is again a task, a manual task. So this can be even handled automatically through Terraform. Infrastructure provisioning tool means it can help us create the infrastructure. Terraform is a tool for building, changing, and versioning infrastructure safely and efficiently. Right? It can help us build the infrastructure, change it, or else you modify it. Right? You can replicate it. All of them are possible with Terraform. So Terraform is an open source and uses declarative language. Declarative language means you have to tell what you need, that's all. Okay, you need not tell about how to achieve it. You need not write the steps of how to achieve it, right? So Terraform is open source and uses declarative language. It helps in infrastructure provisioning, and it uses infrastructure as a code concept, IAC. What is meant by infrastructure as code concept? See, we all know that developers write the code to develop some applications. Similarly, testers also do write some code for test cases and all, right? So, writing a code to manage the infrastructure or else looking at the infrastructure in the form of code is nothing but infrastructure as a code concept, IAC. Right, I repeat. So, managing your infrastructure with code, or else you look at the infrastructure in the form of code. Okay, you just look at the code in the form, look at the infrastructure in the form of code, manage it in the form of code. You can even maintain the versions of the code, means maintain the versions of your infrastructure, which is nothing but IAC. Terraform code is written in HashiCorp language, which is HCL. Right, that's a language it uses. It's very easy to use, and we'll be learning that. So that's what Terraform does. Basically, it's an infrastructure as a code tool, which is open source, where you will write the code using HCL. And there are differences with respect to Ansible and Terraform. Like Ansible also sounds and looks similar. That's called configuration management tool. Ansible is called, Terraform is called infrastructure provisioning tool. They does both almost the same. Like whatever you do with Ansible can be done with Terraform and vice versa. Then what is the difference? Where comes the difference? The difference comes, or the difference lies with the strengths of each tool. Terraform is more into infrastructure provisioning, whereas Ansible is into configuring the infrastructure. Means Terraform, let's make it simple. Terraform is more into creating the infrastructure, whereas Ansible will help you configure the infrastructure. Like already infrastructure is there. You want to install some packages, you want to deploy some Docker containers. That's where Terraform, Ansible comes in. Right? First, to create the infrastructure, Terraform is the one that's used. Then later to configure the same, we have Ansible. And it's more mature and it's a new tool. Infrastructure as a code tool. Both uses the concept of IAC. Means in both the tools, we write the code, we use the code to manage or to configure the infrastructure. So that's where their strength lies. Even though, like I said, each tool can be used for any purpose, they have their own strengths. Once we deep dive into the tools, you can understand these differences as well. And coming to the Terraform architecture, there were two components in the Terraform architecture. One is core and the other one is provider. So Terraform architecture is basically very simple. You can install Terraform on any OS, either in your Mac or on Windows or Linux. It need not be on any EC2 instance. It can be somewhere else as well, right? So first component is core. Core is nothing but the main component of Terraform. Okay, as the name says, it's a core component. It's a main component of Terraform. And what this code does, it will take two inputs. One is Terraform config files written by Terraform users like us. We write Terraform config files. That's the first input. Second one is the state of the infrastructure. What is meant by that? See, Terraform configurations are written by users like us, like just now I mentioned. We write the Terraform code, which is nothing but Terraform config file. And this Terraform config file will have the desired state of the infrastructure, like what you want to have in your infrastructure. Okay. And whenever you apply that configuration, the current state, actual state of the infrastructure will be present in the state file. State file will be automatically generated. Right, whenever you apply the configuration, state file will be automatically generated, which will have the current state of the infrastructure. Right? So both are given as an input to the core component. Okay. So both are given as an input to the core component, and yeah. So this core component will take up this Terraform config file, which have the desired state, and the state file, which have the actual state of the infrastructure. It will compare them and it will create a plan. So what is Terraform plan? Terraform plan is like a document which will have all the configurations to be done, like what configurations to be done and all. So that's a core component which will take Terraform config file, which will have state file, which will compare those, and this core will apply the plan. Right, like let's say on AWS, I want to create an EC2 instance. So, but how does the plan executed, or how is that plan applied? That's where comes something called providers, right? Provider is nothing but, like, you can consider it like a plugin or a software or whatever. It's actually a bunch of code which gives you control over the complete API. Like let's say I want to work on or automate the infrastructure on AWS, right? So there is an AWS provider which can give you control over the whole AWS API. Or else I want to automate infrastructure on DCP or Prem or Kubernetes. You have thousands of providers. Let me show you a provider. Terraform providers will take you to the official documentation, registry.terraform.io. Okay, here you have got this provider, AWS provider. Do you see that? So this is the AWS provider. If you just go here, you can see lifecycle management of, and by the way, see, there are hundreds of providers you can see. Some are officially supported, means some are managed by HCL. Providers are logical abstraction of an upstream API. They're responsible for understanding API interactions and exposing resources. Right? That's what is taken care by these providers, officially supported by HCL, HashiCorp. And yeah, if you click on a particular provider, there is again a clean document. Like I said, it's a code. So how to use this provider? You have to put this code. Okay, in the in the Terraform block, you have got required providers, AWS, okay, provider. So you have got this code which will install that particular provider, and you have a documentation for a provider. See, here are all the services. There are hundreds of services in AWS. If you see, there are so many services, hundreds of services. All those services are listed here as resources. Suppose I want to create an EC2 instance. You search for it, like you see EC2. There'll be something called EC2 resource. Check for it, Elastic Compute Cloud. Okay, there should be something like, yes, AWS instance. That's a resource. That's a resource will help you create a particular resource on AWS. Provides an EC2 instance resource. This allows instances to be created, updated, and deleted. And how to do that? Here is the code. You can understand this code. There is also documentation explaining the code, which will create you the info. Every parameter is explained. What is meant by root block device? What is meant by private IP? What is secondary private IP? Everything. Right? Terraform documentation is very good, that you can get a clean understanding of what you are doing. You can learn Terraform easily with this documentation. Okay, Terraform documentation is very good. That's actually a strength. Okay, when you are learning Terraform, it will help you a lot. So, like officially in the official projects also, this is how you refer the document and do it. Even for certifications also, it's an open book exam. Even the Terraform, no, Terraform is not open book, I believe. Yeah, we don't refer. We can refer, but only certain pages you can refer in Terraform, because Terraform certification is all objective type. So we don't have enough time, or we don't look into the documentation much. But still, yeah, you have certain pages like official references are allowed. Kubernetes also, of course, official pages are allowed. Yeah, it's a completely open book. So you need to make a habit of going through this documentation, understand and use it, because there's like hundreds of code example usage you have so many examples here if you see. So it's not that you need to learn all the code, you have to remember everything in an interview perspective, or else certification, or else for projects also. This is how you refer in interview also. If you are asked to write a bunch of code, definitely you can refer this. Okay, so coming back, yeah, that's about the provider. Right, you have hundreds of providers like Azure, Azure GCP, AWS, Kubernetes. So many providers are there. Thousands of providers are there, and each provider gives access to number of resources. And yeah, it works on Windows, Linux. You can install Terraform, which is very simple. And also, once you write Terraform config files, all of them will be version controlled by Git. Even the Kubernetes manifest files, we have written so many files, right? Even they can be version controlled with Git. We know how to version control them with Git, right? Git add, Git commit and all. So Terraform also the same. That's what is actually IAC. You put everything, the version control system, maintain it as a code. So again, coming to providers in detail, providers or logical abstraction. They have vast number of providers. Each providers offer access to hundreds of resources. And then what are resources, data sources, changing, modifying, destroying the resources, different Terraform commands, state files, output values, and so on. So it is more of a hands-on than theory, Terraform in particular. So let's get started. Let us install Terraform. See, I want to automate the infrastructure here. You may create some other instance here. From there you can automate. But I would prefer automating from my local computer. That's the whole idea, right? Why should I step in even to AWS? Why can't I manage it from my local system? So let us install Terraform on my laptop. It is very simple installing Terraform. Okay, if you just go here, you have how to install Terraform on different operating systems. If you see Mac, Windows, Linux, Solaris, and so on. So if it is Windows, you can just download this. You will get a zip file. I did that actually. Terraform. Oh. So you will get a zip file. Extract it and place it in some folder. Actually, I had it in program files. Maybe in the downloads only I have extracted Terraform. Okay, in the downloads only I have extracted 1.29 or 1.36, whatever it is. Any version you can just download and extract it a folder like this. And when you open, you will say this is your Terraform application or executable. Copy this address. You have to set an environment variable. Go to properties, advanced system settings, environment variables, path variable, edit. Okay, and add the Terraform path here. Do you see this? Add a new variable, put the Terraform path. Okay, you have to put this path. Sorry, in the downloads only I have. Okay, this address you have to put. So that's what I have done. So that you can use Terraform from any location. Right? Hope you know setting up the path environment variable. That's all. That will install you Terraform. Now you can run this Terraform command from anywhere. You may launch Git Bash separately. I would like to launch it from VS Code Editor. Terraform version will do. Okay, Terraform is installed. Perfect. Now we are all good to go and write some Terraform code. Here I'm going to create a new folder. Okay, so just I have created a new project. I would prefer bash terminal, git bash. Okay, so this is your folder. This is where I want to put some Terraform code. Okay, Terraform is installed. Now we are all ready to write some code. Okay, so yeah, I have created some folder and here I would like to use the provider called AWS. Why AWS provider? I want to create some EC2 instance or do some automation on AWS. So how to do that? Again, let's go to the providers documentation. Here you have a bunch of code how to use AWS. Okay, just copy this whole part. See, it says to install this provider, copy and paste this code into your Terraform configuration. Okay, so create a file here. Any name you can give. Generally, we give main.tf for the main for the first file. Okay, you may give any name. So yes, I have got here Terraform required providers. Okay, AWS. So it will install this provider, the latest version. And here comes the configuration options. Configuration options are like, you can just see their usage. Documentation, see here. Okay, this is how you put. And the region you may put here in the configuration path. I mean, in the configure the AWS, provider AWS, here you can put the region where you want. Also the AWS access key and secret key. Let me show you. See here. Credentials can be provided by a plugin, or else this is what you should place. In which region you want to automate. Okay. So let's say I just want to automate in AWS, AP South 1. AP South 1. Access key, secret key. Okay, we have our access key, secret key, right? You have to add those access key, secret key here. Access key. Is it a good practice to put the access key, secret key here? Right? So what you can do, you can do it, if you are doing it via Jenkins, you can store them in the Jenkins credential store like we did earlier, right? Or else what you can do here, AWS configure. Okay, so it will ask you for the credentials. Put the credentials. Similarly, secret access key. I'm stopping the screen share for a while. And the region also you can set here also. It will ask for the region, right? right? You can see the screen now. If I do, because I already entered the credentials, right? Access key is given, secret access key is given, region I have given AP South 1 here also. So it was all set. Okay, done. So this is how you can set them rather than setting them here. Because I have set the region already, you may remove it from here. That's all. Okay, that's the first thing. So we are connected to our AWS account. So now, you can use this, but before that, I'm going to have Terraform config files, which I want to version control. Okay, I just want to version control all of them in Git, this main.tf. So I would also create one more file, .git ignore. Okay, why this? See, whenever I install this Terraform, means whenever I run the code, it will install this provider. Install this provider means provider is nothing but an executable. Okay, it will download an executable, which is very huge. Okay, I don't want to even version control it. Right, so it will be placed in a folder called TF. So I just want to ignore it. Local TF directories. It will start with Terraform. So everything under this. You will understand this in a while. Just give me a minute. Okay. I have added this. Now first version control it. Git in it. Okay, done. So it will be all version controlled by it. Git add. Git commit -m tf code. This is the practical implementation of Git. Earlier we have learned Git to version control dummy files, right? But this is the practical implementation of using Git. So done. Now, we are version controlling it. Now let us install this provider first. So how do you do that? Terraform init. Okay, what this command will do, it will install, download all the providers we need to execute the code. Okay, so let us run Terraform init. You should run it in the directory where you have this provider file. See, initializing the backend provider plugins. What is backend we will learn. Let it finish. See, it was installing this version. You can see Terraform directory created the backend. You all see that. You should not version control this. See, that's why I have placed. Why you should not version control this? Because it's an executable. Okay, it's a huge file. You don't need to version control it. Right? See, Terraform has been successfully initialized. You may now begin with the Terraform. Try running Terraform plan to see any changes that are required in your infrastructure. All Terraform commands should work now. Okay, so yes, Terraform has been successfully initialized. See, this folder is created. If you see, it will have this executable. See, it will not display. It's an exe. Do you all see that? Terraform provider AWS 4.48. That's a version. It's an exe. See, this basic information one should have to test your real experience. Those might be the questions from an interviewer. Like when you do Terraform init, what happens? What is the .terraform directory? These are all different questions you may have. See, I'm just going here. See, this is the one. Here in the Explorer, you may not visualize it properly. I'm showing you here. See, open it. Providers, that's a path. There you have got an executable. See, this is what I am trying to open here. This is the path it was showing if you see. Do you see the path? Providers, registry, hash, that's the path I have just opened now. This path. Making sense, everyone? So that's a path. All of this actually are self-explanatory. Means when you are doing hands-on, you can analyze what is this, what is happening and all to make the things more simple for you. So that in the second try, when you are running these commands, you will get a consciousness of watching all these things. That's why I'm explaining these things. Okay, that is what is happening. So you don't need to version control an executable with Git. So ignoring it. And along with that, another file will be created called Terraform log file. This is another important question from the point of interview. What is a log file? When is this log file created? Log file is created whenever you install a new provider. It will have all the information of the provider you have installed. And should this be version controlled? Yes, this should be version control, because when someone sees this, they know which version of provider, which version of modules we are using, what are modules we'll learn. So it will have all the information. So this can be version controlled. Okay, so you don't need to ignore it, add it. Perfect. We have got a provider installed. We have configured our AWS account, right? Everything is done. Now, okay, let's take up a simple example. I want to create an EC2 instance. Okay, so like I said, search here, whatever you want to do. Let's say I just want to create an EC2 instance. You have a resource called AWS instance. Okay, I'll just use a simple one, very simple one. I'll copy this block. This is just very basic way of doing it. Let's start with the basic. Okay, resource. You should understand in Terraform, whenever you see resource means, yes, this will create a resource. This block will create a resource. And it will have type of, which type of resource? Is it creating a load balancer? Is it creating an S3 bucket? Or is it creating an EC2 instance? What is it creating? That's a type. And then name means, okay, EC2 instance is, what is the name you want to give to your EC2 instance? I want to give the name as web, right? Or else let's say instance name is demo instance, right? And you have to provide the AMI for your instance, right? You have to provide the AMI. What is AMI? What is the AMI? Anyone knows what is an AMI? So no one knows what is an AMI. Whenever we are creating an instance, you might have seen here, Amazon machine image. This is called AMI. We are using Amazon Linux 2 AMI. See AMI. Amazon machine image. We are spinning up instances from Amazon Linux 2. There were so many else. We have discussed this already. So you have to provide the image ID, AMI, right? The machine ID you can provide. Here it is. Okay, you can copy from here. Here you can see the same, right? So copy from here and provide it. There are multiple ways of providing the AMI. This is the basic way again, right? And which instance? I just need t2.micro. Do you want to put the tag? Tag is nothing but whenever you're creating instances, you will see here name, right? This is the tag. Or else you can also see the tags here. When you select it, you will see tag at the here. Tag, some name and the value. Okay, that's your tag. So this will create an instance from this AMI, which is of type t2.micro, and the tag would be hello world. Right? This is the name in the Terraform code with which I can refer to. Means if I want to refer to this resource, I'll call it as demo. But this is for display on AWS console. Am I making sense? Is anyone there in the class?
It's clear.
Thank you, Swarna, for confirming. Okay, so now I just want to apply this code. So before applying straight away, you can run the command Terraform plan. We have just learned, right? Terraform will create a plan when you run this. What it will do, this is your Terraform config file. It will compare this. This is your desired infrastructure. It will compare this with the actual infrastructure. Okay, let us run. It will not really create the infrastructure. It will just show you. It's like a dry run. It will show you a preview and observe at the back end what is happening. Whenever I do Terraform plan, state file is created and gone. Okay, it's okay. Means state file is getting processed. And what this does, see here. Whenever you do Terraform plan, Terraform uses the selected providers to generate the execution plan. This is the plan it will create. It's like a document which will show you what happens when you apply this. Okay, so resource actions are indicated. Plus means it will create those resources. Okay, see AMI, yes, you have specified. Did you specify the public IP? Did you specify the availability zone? Did you specify the CPU core count? No. Means if you don't specify, they will be applied and the default values will be used. Because I have applied this T2.micro. Otherwise, known after apply means once it is created, you will know those values. You can customize, you can pass all these values like we passed AMI. Getting me everyone. See, Terraform is very, very important nowadays. There were a lot of projects looking for Terraform resources. If you know Terraform, that is going to be a great advantage for you. Just give me 1 second. Okay, so it will use plus means all those resources will be created. Right? Just give me 1 second, please. 1 second. I'm sorry. So all of this will be created. Okay. We can also configure like if you want to automate, like if you want to customize anything, we can. Okay. We'll also do that. If you don't provide them, default values will be applied. This is like creating a basic EC2 instance. Till now, what we are doing, we are just going and creating instance again with the basic details only. What I mean is, see, we were creating instances till now. We were not configuring the security as we like. We were not assigning VPC to them. We were not assigning IP addresses. We were not doing anything actually. Only we were choosing the type of the instance and just the name. That's all we were doing from the AWS management console also. But you can create your own EC2 instance with all the custom configurations. Okay, we will do that later with the Terraform. So that's what are all this. Because I'm not providing those values, they were all shown like known after apply. Okay. So it says one to add means it will create one instance. Okay, fine. I just want to apply them. I don't want to create it. As of now, it doesn't create. It's just a plan. Okay, it's not created in AP South 1. We have chosen the region, right? So it has not. So now we will do Terraform apply. Okay. Terraform apply will create the instance. See again the state file if you see. And again it is showing all of that. And do you want to continue? Like confirmation should be given. Yes. Then only it will create. It will create the instance now. And at the back end you can see state file and state backup file will be created. For the first time when you apply Terraform command, state file will be created. State file will have the current state of the infrastructure. Means as per this Terraform code, one EC2 instance is created. All that information will be present here. So you can see here one resource is added, right? So let's see. Now if we refresh, we should see like, yes, right? It is running, it is created, it was initializing, and you have the tag hello world added. Got it, everyone? Right? Your EC2 instance is ready. You can do SSH if you have attached a key pair. We didn't attach the key pair, but still you can connect with a browser-based connect this way. Or else you can put a key pair as well. Right? Just like again a normal EC2 instance. Interesting, isn't it? So the manual step, whichever we had, can be automated this way. Creating the infrastructure. This is what Terraform does. So it is creating one instance. What if I want to create multiple instances? Let's say I want to create 2 instances. By the way, before that, one more thing. See, state file is created. State file will show the current state of the infrastructure. Okay, everything, your AMI, everything. So many values were assigned after creating, right? Like CPU core count, IP address, okay, the password, everything will be present in state file. So state file is again a confidential file. You cannot version control and put it on Git because like I said, it will have every information of your instance, including the key pair values, including the IP address, everything. So we don't want to version control it. So ignore the state file as well. That's what is a git ignore file we have used. Don't version control this. So Terraform state files. Okay. So anything starting, ending with Terraform state should not be version controlled. I'm adding here one more thing. State.backup. You will see this file also will be created. I'll tell you about this file. So this also should not be version controlled, which may have sensitive data like passwords, IP address of your instances and so on. Okay. So git add, that should not be version controlled. See, this is not being version controlled. Okay, so yeah, state files will not be version controlled. And this Terraform directory should not be version controlled. Now, okay, let's say I want to create 2 instances. There is something like meta parameter count equal to 2. Okay, that will create 2 instances or 3, whatever you want. So again, you can do a plan before applying. Okay, so that is about the Terraform plan. It should show you create. It is creating one more instance with the same tag. Okay, see, unchanged blocks are 7, unchanged attributes are so many, 1 to add. it will create one more. Or else what I will do is, I need two instances. I would also like to put the tag name as like something like TF1, TF2 and all, not like hello world. So what I can do is TF hyphen count will provide you an index that can be referred with a dollar, like count dot index. Okay, count dot index means 0. Indexing starts from 0. So TF0, TF1. So two instances will have a different tag. So let us plan and then apply. I'm directly doing apply. Confirm. This is the second time I'm running apply, right? So whenever you do Terraform apply second time, another file called Terraform TF state backup file will be created. I'm repeating, for the first time in your project, when you run Terraform, you cannot open it because changes were happening. Okay, you can open it later. So whenever you apply Terraform, whenever you run Terraform apply for the first time, state file will be created. Second time, state file, tf state.backup file will be created. What is that? Let me tell you. See, state file will have the current state of the infrastructure, means two instances information, right? You can see here, two instances information will be present in the state file. Yeah, demo, and it should be Terraform.0. There should be name somewhere. Is it reloaded? Okay. Yeah. See Terraform 0. And also there should be one more instance, Terraform-1. Two instances, right? See. Okay. So Terraform state will have the current state of the infrastructure. As of now, two instances data is there. Backup file means it will have the previous state. Previous state means how many instances we have in the previous state? Only one, right? So that is present in the backup file. So that is the importance of these. It will have the previous state, it will have the current state. And one added and one changed. Earlier existing one tag is changed and one more new one is added. In total, there should be two. See, existing one tag is changed and new one is created. So that's what is one added and one changed. Do you see that? Two instances now. Any questions? Is it clear? So both of them should not be version controlled. That's why I have added both of them in the ignore file. That is the practical implementation of .ignore file. Version controlling Terraform files, Kubernetes files, and so on. Right? So this is how you create the infrastructure. You can modify the infrastructure. Let's say I want to create T3.micro. Okay. Just again do apply. You may run plan before that. What I'll do is, I'll not apply. It will ask for confirmation, right? I'll say no. I'm cancelling it. So it will not apply. Only if you put yes, it will. So I'm making it. You can modify the infrastructure. Terraform plan will show you very clearly. Before running apply, always make sure you're doing plan. Okay, so that you know, okay, whether this is the change you want or not. And if something is changing, it will be shown with the tilde operator. See, tilde means updates. So what should be updated? Instance type should be changed to t2.micro to t3.micro for both instances. So that's a change. So to change. Interesting, isn't it? It's very easy and simple if you follow all of this perfectly, conceptually. When I do Terraform apply, it will ask for yes or no. If you don't want it, you can add here itself. Auto approve. So that it will not prompt for confirmation again. So they will be modified to t3 dot small rather than t2 dot small. You just go here. Where is this? Yeah, t2.micro. It should be changed. So let us wait and see. It will be changed. It is t2.micro. Still applying, right? Still modifying. So you have to wait. Okay, 2 changed. Let's see. Right? Do you see that? They were all changed to t3.micro. Right? So even you can create the infrastructure. This is about modifying the infrastructure. And you can also destroy the infrastructure. How do you destroy? Okay, my job is done. My tasks are completed. I don't want it. Terraform destroy. Terraform destroy will destroy the complete infrastructure. Whatever is created from this config file, everything. See here, minus indicates destruction. Here the symbol indicates destroyed. All of these will be destroyed. Okay, confirm with yes. Everything goes destroyed. Destroying. Okay, see, do you see that? They were all shutting down and terminating. See, still destroying. Okay, 2 destroyed. So what is the current state of the infrastructure? Say terminated, like deleted also. So current state is 0. State file will show you the current state. Because it's 0, file is blank. Do you see that? But state backup file will have the previous state of two instances information. Hope you understand state file and state backup file now clearly. And if you want to apply them again, let's say this time t2.micro. Okay, I'm doing it again. Terraform apply. Okay, so 2 instances will be created. Obviously, you can see here the instances. Okay, you can see TF1, TF0. Now the state file will have all the 2 states. Backup file will have the previous state. Previous state 0, right? So that's how it will rotate between the state file and state backup file. Okay, and so yeah, state file will have all the information. Like see all the information of that instance. So if you want to see what are all created, you can see Terraform state list. It will list all the resources it has created. See, 2 instances. AWS instance. What it will show you, like name of the instance, sorry, type, this one, dot name. Do you see that? That's a name we refer in Terraform code. That's why demo.0. But I want to see all the information of this particular instance. Okay, you may just copy this and run another command. Terraform show, sorry, Terraform state show. That instance name you want to see. Sorry. I want to say this one. It will show you all the information of this particular instance only. If you say state file, both the instances, all the infrastructure information, it's very difficult to search it. This is how you can see only that information, right? So all the data, whatever it has created, everything you can do. Public IP, public DNS, everything you can, right? And okay, fine, it is showing all the information, but I don't want all the information and I don't want to check it in the console. Rather, I just want to print some data. Okay, I just want to print some data once the instance is created. That's where comes something called output values. Output, name of the, some name you can give IP. I just want to print the IP. So value equal to, how do you refer it? Type of the resource. What is the type of the resource? This one. Name of the resource. What is the name of the resource? Like just now we have seen demo dot, like let's say I just want to see first instance IP address. Okay, that is the first instance dot public IP or what? See, when you give, see, this is the whole object. Okay, that will give you the entire instance, isn't it? Just now I have shown you. This will give you the entire EC2 instance, first EC2 instance. So it has got lot of information, lot of properties. Which property you want? Dot, right? It will list here. You want to see public DNS or whatever. Okay, so let's say I just want to print it. Now if you do Terraform apply again. By the way, one more thing. Already instance is there. If I do Terraform apply, what happens? Already EC2 instance is there. Forget about this output value. What happens if I run apply again? Will it recreate? It will not recreate. Okay, Terraform, any infrastructure as a code tool follows the concept called idempotency. Idempotency is nothing but if configurations were in place, you will not reapply them. You don't need to reapply those configurations. Right? Means Terraform will not reapply them. If everything is in place, it just says they were in place. It will not recreate them. If it is just doing that, there's no point of using Terraform, right? So it follows idempotency, means if configurations are in place, it will not reapply or recreate the things. If things were not in place, then it will force them to be in place. Because here everything is in place. So it just should say, see, nothing to be changed, right? You don't need to change just the output value it has to print. See, this is the public DNS. Means anything if you want to see from the console, you need not go to the console. tf.0 means this one, right? I have checked this. This is the public DNS. Correct? See the same one. You don't need to go to the AWS console to check some values. You can use output values. Okay, if you reapply the changes, it will not recreate them. It follows idempotency. But suppose, okay, we have seen nothing to change. 0 to add, 0 to change, 0 to be destroyed. Nothing. No changes required. Your infrastructure matches the configuration. Means whatever is actually there matches your desired state. Suppose someone manually changed the stack, okay, to Terraform 0 dot experiment. Okay, now someone manually made those changes. So now I am doing Terraform apply. What it will do? It will not allow that. Okay, it will say that something should be changed. As per the code, it will put it in place. See, this is this, but as per the code, it should be this way. So one change, do you see that? Tag name will be changed again, it will be in place. This is what is idempotency. Right? See, it was back to its place. Following everyone, these concepts are very important. In interview, they may be asking if someone changed the infrastructure manually. Okay, will the Terraform code work or will it give error? What happens? What happens? It will reapply. So once you are using the code, once you are applying from Terraform, whatever changes to be done should be handled only from here. Don't do it from the console. Okay. Again, I want to delete everything. Terraform. This is the complete life cycle of Terraform. Creating, updating, deleting. Destroy will destroy the whole infrastructure. But I want to destroy only certain targets. What you can do? I don't want to destroy whole infrastructure. Only certain resources. Let's say only the first resource I want to delete. So you can use target. Okay, Terraform, destroy target and the name. How do you refer it? With the type and the name. Name is demo dot. It's a first one, so demo dot 0. Okay, only that target will be destroyed. It is stuck up. Shall bash. It got stuck up. First go to this path. Okay, we are into the right directory. Now apply this command. Terraform destroy. Target, type and name. Okay, it should destroy only that infrastructure. This got hanged up. So yeah, see, it was deleting everything. It's asking for confirmation. Only one to destroy. Two resources are there, but is destroying only one. Confirm. You can also use auto approve with destroy also. Okay, one destroyed. So let us see. See, do you see that Terraform.0 got destroyed? It is still there. So what happens if I run Terraform apply now from this core? What happens if I run Terraform apply? In the same code. Okay, here as per the code. This is the code. Now if I do Terraform apply, what happens?
It will create another instance, right?
It will create another instance. It will create one more instance, right? Because the current state should match the desired state. Okay, fine. Now I am again doing Terraform destroy. So now whole infrastructure should be destroyed. Anyway, only one is there, so that will be destroyed. Okay, confirm. Total infrastructure will be destroyed. Right, it was shutting down and already got terminated, some of them. So yeah, everything is destroyed. Now we were talking about infrastructure as a core concept. What does it say as per the code? How many resources should be there as per the code? And state file has become empty, state backup file will have to. So, but as per this code, when someone see I place this code on version control system, my team members see this and they assume that 2 resources should be there. But that was not the case because I have destroyed them, right? Means your current state is not matching this configuration, right? Whenever someone applies, again they'll be created. So this is not how you should destroy your infrastructure. If you don't want this infrastructure, what you should do, you should remove the code. Okay, you should remove the infrastructure. I'm deleting it. You should do this. Right? Then do Terraform apply. Then it will do like what you want, right? So now if someone sees the code, yes, they can understand. Okay, because as per the code now, this is the code. And that is the infrastructure. Apply complete 0 tab because already we destroyed. Right? So this is another way to destroy. Remove the code. Okay, apply it. Then the infrastructure will be destroyed. But don't use destroy command. Means always your infrastructure should match this config file. If you don't want something or else if you want to modify something, do it with code only. Don't do it with console or don't use destroy commands. If you use destroy command, this is what is happening. This is again an important interview question. If you don't want some resources, how do you destroy them? What is the best practice? Would you destroy using destroy command or else you from the code? Always from the code. Am I making sense? So always destroy from the code so that your code should match the current configurations or the desired configurations. Alright? So that's a complete life cycle of Terraform. Creating, modifying, destroying, different ways of destroying. And there were many things like data sources were there, variables, how do you parameterize your code, how do you apply the code for multiple instances, modules, so many advanced concepts are there. So any questions till this part from anyone? Okay, I just have the code again. So you can use output values and so on.
If you want to create two different instance types, so do we need to have two resource flags?
Two different instances meaning? Two total different
Instance types,
configurations?
one micro, one medium.
Yeah. What you can do is, yes, you can remove this, create two separate blocks or else you parameterize it. Means don't hard code this. Okay. What I'll do here, we can define a variable for it. Variable for some name to your variable instance type. Okay, define it first and then here instead of hard coding it, var dot instance type. Right? Okay. So understood. So what you will do? New bash terminal. Okay, Terraform apply or else first do Terraform plan. Okay, I just have a parameterize. This is how you define the variable name and then use the variable with var dot. When you do apply, it will ask which type of instance you need. Do you see that? One way is, yes, pass the value this way. Of course, because again here two are there, right? I'll talk about multiple also. So this is one way you can handle the variables. First, let's talk about defining the variables. So this is one way. Or else what you can do is you can create one more file called Terraform.tfvars. That should be the file name. It should not be anything else. Here you define the value so that it will not prompt for the value again. Okay, it will not prompt you. You may go for command line prompt, or else you may use this value and do it. Okay, again the same. T2.micro will be applied because I have given the value. And like, what if you want to create two separate resources? When you do Terraform apply also, it will by default take the values from TFVAR. So you don't need to put the file name. Okay, so you may confirm it. It will create with the T2.micro. You can see here T2.micro. Okay, let's say you want to create multiple instances, like both are not of same type. Let me just remove this count parameter. And here I just want to say Terraform instance, Terraform EC2. It should be the name. Okay. The same block I want to create multiple instances. Okay, what this also will not work now. Demo dot. That's all because there is no count. Okay. Now one I want to create multiple instances. What you can do is apply will take values from here. Okay, I just want to have different value also. When you are rerunning, you can change the value here. Okay, but that's not the efficient way. If you want the same infrastructure to replicate it with different configurations, we'll be using another advanced concept called workspaces. Workspaces we'll learn later. Until then, what you can do, change the value here and create again. Or else, you may have another variable file, Terraform demo, or else for dev environment, dev.tfvars. Okay. T3.medium. So whichever value you want. See, when you run Terraform apply, by default, it will take a values from terraform.tfvars. That's a default file. But if you want to pass another value, another file, var file, terraform.dev.tfvars. Then it will take values from this file and it will create. But this is not efficient way because each time you have to do separately. One time this one, next time this one. Okay, like if you just go here, T3.medium. Okay, but if you want to replicate, if you want to create at the same time, you will be using something called workspaces. Okay, that part we shall take up as we progress. But here you can see passing the values from the command line and from the file. Understood the two values of passing the, two ways of passing the variables?
Yeah.
There is also another way. Like whenever you do Terraform apply or Terraform plan, if you don't have this default file, let's say I'm deleting it. It will definitely ask you for the value. You should have mentioned this file name. Otherwise, it will prompt. Or else what you can do is, that's one way when you give values in the prompt. Or else you can do var, okay, and the variable name. This is another way. Instead of waiting for the prompt, this is how you can do. So it will not give you any prompt, but it will take this value and create the plan. Okay, those are the different ways. One is through command prompt, like it will ask you. Second one is by passing a var attribute, or else by using a variable file. Three ways of passing the values. But the same infrastructure. Okay, only one EC2 instance. But I want T2.micro, T3.medium also parallelly, not one after the other, right? Like I want them parallelly, right? Replicate the infrastructure parallelly. That's where comes workspaces into picture. We'll discuss that as we progress. Okay. And we have something called data sources. Data sources, and then we'll talk about creating EC2 instance with all custom configurations, like with our own VPC, with our security groups and all. We have given security groups, we can give SSH key pair, right? But we didn't give all of that, just a basic EC2 instance. So how to do all those customization, we shall take up in the next session. First, we'll talk about what is a data, what is a VPC, what is subnet. Okay, we'll discuss about some of the AWS resources and we shall go. Any questions from anyone? All right, then we shall continue from here tomorrow. Bye everyone. Thank you all.
Thank you.